All right. Colored pens up. So, this type of material is not too conducive to getting volunteers, so let me just reveal the graph that you should have drawn. And here is the graph that you should have gotten. And the computer program I use doesn't let me do arrows, so let me add those in. Of course, there are arrows on either end. Now, before you mark yours wrong or right, a couple of things. The most important thing is getting the correct graph. There is more than one way to get the correct graph. So how do you know you have the correct graph? Here is how you know, so watch carefully. First, when I show you something to look at, you're going to look at your own paper. I would like you to look and see if your line crosses the y-axis at -3. So see if yours crosses at -3. If it does not cross at -3, then unfortunately your graph is incorrect. The second part is where it crosses the x-axis. It should cross at exactly 6. So check and see if your graph crosses at 6. Now, here's where, if you did not have a point over here and you used your ruler to draw a line, it's possible that the line was a little bit off of 6. So if your line was a little bit off, that is okay. But if your line is nowhere near the 6, then that is not okay. You have to have it passing through both of these points, and then you know you have the correct line. So now go ahead and mark your answer correct or incorrect. Now, it's possible that you did some of the work correctly, but the ultimate goal is to have the correct graph. So now I'm going to show you the table that I used to construct this graph. And here's the table that I used. Now, don't mark your table correct or incorrect or anything like that yet. This warm-up is very intentional. I picked this question specifically because of one detail. So let's explore that one detail. So I'm going to adjust mine for a moment, and you need to watch up here. I'm going to take this out for a moment. So we can focus on something. And I would like you to look at your table. And I would like you to look at your y values. And I'm going to ask a survey question. Give me a thumbs up if you have any fractions in your y values. Give me a thumbs up. Good. Put your thumbs down. Angela, what were your y values?
4, -3, and
Okay.
-3.
Okay. So did you have the same x values that I did?
Yes, but I had 6.
Okay. Good. So if you ended up with fractions, that does not mean you did something wrong, and it doesn't mean that you're a bad person. In fact, if you did it correctly, you should have the exact same graph. Because if you plug in a 1 here, you end up with the ordered pair 1, -2, which is right there. If you plug in a -1, you end up with the ordered pair -1, -3, which is right there. The problem is that it opens you up for computation mistakes. Because watch what happens when you plug in a -1. I'm going to do it over here so we can see it nice and big. 1/2 times -1 minus 3. 1/2 times -1 is -1/2 minus 3. Young people get very messed up with this, even though it's really not a big deal. Here's what it really is. Of course, I'll do the same thing I always do. That's a -1/2, and that's a -3. You put them together, that's -3.5. So should everybody in the room be able to do that? Absolutely, with no problem. Do lots of young people mess that up? Yes. So how do we avoid dealing with fractions? Can someone tell us what I did to avoid having to deal with the fractions? What did I do, Ethan? I used all even numbers. I love the way you said that, too. So let me back up for a second. I have enough experience. You do not. But starting today, you will have enough experience. I saw this right here, and I knew that if I plugged in an odd number, like he just pointed out, a 1, a 3, a 5, a -1, a -3, that I was going to end up with a messy fraction somewhere in here, which means it's hard to graph. So if I just pay attention and look at the denominator right there, I can make simple choices for my x values that will give me whole number y values. By choosing even numbers, I was very easily able to get -4, -3, -2, -1. So now moving forward, you should be able to do that yourself. You may recall during the last lesson, I kept saying -1, 0, 1, and 2 is usually going to work, but it's not always the best choice. Does anyone have any questions about this? So now let's build from there, and let's just rapid fire look at something related. What if the function was y equals 1/3 x plus 9? What x values should I choose so that my y values come out really nice and friendly? Don't answer that yet. What if the function was y equals 1/5 minus, I don't know, 7? What x values should I choose so that I get whole numbers in the y value? Think about it for a moment. Good, let's go back to this one on the left. Anyone have an idea of what numbers I could choose to get whole number values? We got 3 people who are starting to catch on. Good. Emily?
-3, 0, 3, 6.
-3, 0, 3, and 6. Mark, what do you think about that? You think that's a good choice? Yeah, because look, the denominator's 3. If we use multiples of 3, it will get rid of the denominator for us. What's 6 divided by 3? It's 2. 2 plus 9 is 11. We get a whole number. If I chose -1, 0, 1, and 2, look how messy this becomes. -1, 0, 1, 2. -1 times 1/3 is -1/3. Plus that, I get 8 2/3. Is that easy to graph? No, because look at where I would have to go. -1, 8 2/3. I would have to estimate 2/3. And so my graph becomes inaccurate. 0 wouldn't be a big deal, but then the 1 would be 9 1/3, and then the 2 would be 9 2/3. And so now I have this very uncomfortable graph to make. So don't do that. Stick with numbers that will make your life easier. What about this over here on the right? What would be good choices for the x values in this situation? One, 2, 3, 4, 5, 6, 7. Deja, and then Angela. Okay, what do you think?
-5, 0, 5.
Yeah, those would be great choices. You could do anything that's a multiple of 5. You could do -10, -5, 0, 5, 10, 15. Anything that's a multiple of 5 will make this disappear and turn it into a whole number. -5 times 1/5 is -1. -1 minus 7 is -8. Now I have something very easy to graph. So you have to think about it. You cannot be robot student. You cannot be, Mr. Gallant said, must use -1, 0, 1, and 2, so that's what I'll do. You can't be like that. You have to think to yourself, hey, I'm an intelligent young person. Mr. Gallup said that negative 1, 0, 1, and 2 might work, but maybe there's a better choice depending on the situation. So you have to use your brain. Are there any comments, questions about the idea of dealing with the fraction by choosing making creative choices with the x's? Any questions? Good. So we have been part of a building process for a long time. I keep using the same terminology of building and building. And we've been building throughout chapter 3, but we've actually been building since the beginning of chapter 1. In fact, we have been building up to today. 6 weeks building up to this. That's a lot of work. You are going to incorporate everything you've learned for the most part. Today we're going to explore what a scatter plot is and what trend lines are. The trend lines is really the important part. The rest you actually already know how to do. The idea is to be able to make predictions about things. This is what researchers all over the world are doing. They are doing research on a topic to try and make our world a better place, and they are collecting data, and then they are trying to make predictions of things. They might be making predictions about things that happened in the past, like people who study dinosaurs and prehistoric eras. They might be trying to make predictions about things that will happen in the medical future to try and help us beat cancer or other diseases like that. They collect data and try to make predictions on what will happen. This is a critical piece everywhere. So that's what we're going to be exploring today. So what is a scatter plot? You already know. You've been doing it for several days already. A scatter plot is a graph. It's data points on a graph. It's very effective for showing relationship between sets of data. The idea is this right here. We want to be able to see if there's a relationship between the data. For example, is there a relationship between more time studying and better grades? I don't know. Maybe there is, maybe there isn't. We'll talk about that one again. So now we have the idea of scatter plot. Now, the big boy words. Correlation. You have to know the word correlation, and you have to know the different types. A correlation is a relationship between two sets of data. Identifying the correlation helps you analyze what's happening and allows you to make predictions. That's the key to everything. So there are 3 types of correlations. They are positive, negative, and no. A positive correlation, a negative correlation, and no correlation. So what I have here are just kind of made up sets of data. It's done on purpose. Okay? So we're not looking at specific pieces of information. We're just looking at kind of a pattern. And so when you look at this graph and you look at the data, they seem to be moving in a similar fashion. As we move further to the right this way, we move further up the y-axis. That's what happens when you see this trend. That is called a positive correlation. As one value goes up, the other value goes up. That's the important idea. In other words, this data point right there, the x value comes from here, the y value comes from there. That is different than that data point. That data point, the x value comes from here, and the y value comes from there. So clearly, this data point has higher x value and a higher y value. That's a positive correlation. By contrast, we have a negative correlation. And in this situation, as one value increases, the other one decreases. So look at this data point right there. its x value comes from here. That's a very small x value. But its y value comes from up here, and that's a very high y value. So small x, high y. Now look at this data point all the way over here. The x value is now very high, but the y value is very low. And so that is called a negative correlation. As the x's get bigger and bigger, the y is going down. So what would be examples of this? Let's go back to the studying. The more hours you study, the better you will do on your quarterly exam. So if the x-axis was hours and the y-axis was your score, I would expect to see that as students studied more and more, their scores went up and up and up. And so I could do a study and I could say, Daniela, you can only study for 1 hour. And then I could say, Isabella, you must study for 10 hours. Clearly that would be tough, but I would expect to see a higher score come from her than from her. And so that's the idea. What about a negative correlation with grades? What if I changed it and I said I wanted to see the impact of Xbox on grades? Quarterly exams, since we're in the middle of quarterlies. I would say that the more hours you spend playing Xbox, the lower your grade will get. So right here would be 1 hour of Xbox, high grade. This would be 10 hours of Xbox, very low grade. That's a negative correlation. As one value goes up, the other one goes down. Does anyone have any questions about the ideas or the examples I'm using? All right, and then no correlation. There are many cases where scientists, researchers, all over the world think they see a connection with something, collect data, and then there's nothing there. There's just no relationship. There's no correlation. The data is all over the place. There's some high x's with low y and some low x's with high y, but then there's some that are high, and then there's some that are low and low. It's all over the place. There's no relationship here because the data says there's no relationship. So now here's my third scenario. I think that the color of your shirt will determine the score you earn on your quarterly exam. And so I go around and I collect data from all over the school, and the people wearing blue, and I get their scores in their quarterly, and I get the people wearing white and the scores in their quarterly. And I do a study of all the different colors and all the different scores, and what I would find is that there's absolutely no connection whatsoever between the color that you wear and the score. And the reason is that there's going to be some people wearing blue who get high scores, and there's going to be some people wearing blue who get low scores. And there's going to be some people wearing white who get high scores, and some people wearing white who get low scores. And I'm going to see that for every color. And so there is no correlation whatsoever. Does anyone have any questions on the idea of correlation? So we established the idea of scatter plot. We now know the idea of correlation. The last piece is the idea of a trend line. And the trend line is what allows us to take the correlation and go to the next step, which is make a prediction of what will happen in the future. Here is what a trend line is. A trend line is a line that tries to match the trend of the data. It can help you make predictions. Now, drawing a trend line, and we're going to do this at the latter end of the lesson. What you try to do, and this is where you have to have experience and you have to know what's happening. So the first time you do it, it's not going to be super simple. But we want to draw a perfectly straight line using a ruler through the data so that the line follows the trend of the data. So for example, I could draw a line like this. But does that match the trend of the data? I don't know. Let's propose a different line. Maybe this would be a better line. Would that be better? I don't know. What about that? I don't know. But it seems to me that if I get a line that goes somewhere right through the middle, that I will have done a good job of trying to do a trend line. And here is how you know. First of all, you try to get your line to go through as many points as possible. But that doesn't really matter that much. Here's the key. You need to try and get the same number of points below the line as there are above it. So watch this. Let me put back the line I had that I started. Okay? Let's pretend for a moment that that's a trend line. It's passing through 1, 2, 3 points. But look at how many I have below the line. 1. And look at how many I have above the line. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have way more points above the line than below, so the line is not a good fit. But if I put the line here, now let's see. Now I'm passing through 1, maybe that one, 2, 3, maybe passing through 3. And now let's count how many I have above. 1, 2, 3, 4, 5, and now below. 1, 2, 3, 4, and part of a 5th one. So now I have almost the same number below as I do above. Now I have a good trend line. Do you see how the dots seem to kind of follow the pattern of the line? And so the trend line lets us make predictions. And so nobody knows exactly what will happen in the future. But now that we have an idea of what's happening, we could say, oh, well, the future will happen about right there. And that's the use of the trend line. This is what researchers are doing all over the world. So that's just the beginning of doing trend lines. Does anyone have any questions? Another reason why this is called no correlation, because there's no line that would fit the data properly. Excuse me. I can't draw a line. Yeah, I could get the same number above and below, but it doesn't follow the path of the data. That doesn't really follow the path of the data, and neither does that, and neither does that, and neither does none of them will follow the path of the data. So there is no line that I could draw that will work. Does anyone have any questions? Good, so let's start the building process for today. We're going to start with scatter plots, then we're going to talk about correlation, and we're going to end with actually doing a full study with a trend line. So let's start with just doing a scatter plot. You do not, for today, you do not need to copy the text of the question, you need to read it. Of course, you write example 1a. You need the table of values, and then we're going to draw a graph. So go ahead and get that down quickly, and then let's get started. Remember, you are using graph paper and your ruler. Your graphs are going to need to be not tiny and not gigantic, but somewhere in the middle. So for the first example, I chose something kind of silly, kind of harmless. There's nothing really intense about cookies in a cookie jar and the time since they've been baked. But it will give us a good opportunity to just learn how to make a scatter plot. Now, I don't care if your table is perfect, you just need it down. So, we're going to do a graph, but we have to plan it out. You can't just jump right in because then you won't have enough room. So you have to look at your data, and you have to say, okay, well, that's positive, that's positive, that's positive. Oh, okay, everything's positive. So that detail tells us something. And we talked about that before. When everything's positive, what does that allow us to do for our graph? Aaron? Quadrant, Kianis, what is it called? Quadrant 1. Yeah, it goes, they're numbered, but you have the right idea. So it's quadrant 1, the upper right corner. That's all we need. So let's start with that. So I'm going to draw an x-axis and a y-axis. So that helped me because now I don't have to worry about the other part of the graph. Already got that? Okay, so now the next part is the size of the data. So I have to actually pay attention because this is 1, 2, 3, 4, so that's easy. So I could just do 1, 2, 3, 4 along the bottom. But now my other values are 7, 10, 16, 24. I don't know if I have 24 points on my graph. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I don't have 24, so I can't go by ones on the y-axis. Here's the good thing about real-world scenarios. You can go different intervals on the x-axis and the y-axis. So you can have a different interval as long as you're consistent along the same axis. So for example, this can be 1, 2, 3, 4, 5, 6, 7, going by ones. But since I do not have 24 points on the graph, I need to do something different with the second piece of data, so I'll go by twos. So this will be 2, 4, 6, 8, and so on. But I cannot change it partway along the way. I have to keep it consistent on this axis. So in other words, I can't part way all of a sudden start going by ones. Has to be the same. Does anyone have any questions on how we set up the graph? Now we need the data points. Where are the data points? Like what are they? I don't have any data points. Do we have to write an equation? What do we have to do to get the data points? Got just two people who have an idea. Everyone's too busy doing their graph. Mark, where do we get data points from?
It'll be 1 in the third and 23, 24. Since the cookies, the time, we'll go ahead and the cookies on the side. We'll go like how many or one.
So give me an ordered pair. Well, give me a
1 in 1, 2, 4, 24.
1, comma 24. 1, comma 24. That's an ordered pair right there. That's the x value, that's the y value, that's the ordered pair. So the table is the ordered pairs. It's just not the way we're used to it. We're used to seeing it like this, x, comma, y. But this is the same thing. This is x, comma, y. It's just horizontal, that's all. So the ordered pairs are all there for us already. This is 2, comma 16, 3, comma 10, and 4, comma 7. So, 4 ordered pairs, plot the points. 1, comma 24. 1, 24. 2, comma 16. 2, 16. 3, comma 10. And 4, comma 7. And just because it's an odd number doesn't mean I can't do it. I just have to estimate where the halfway point is between 6 and 8. And now I have a scatter plot with which I can do research. Does anyone have any questions on how we put together the scatter plot? How we got these ordered pairs, why we went by twos, anything at all? All right, so let's see another to make sure we've got the idea of scatter plot down. Part B of example 1, you don't have to copy the text of the question, but again, you need to read it. But you do need the table of data. In this question, we're going to explore what has happened to a particular job and its salary over 5 decades. So again, we're going to construct a scatter plot, but we need to think about the information we have. The top row, 1950, 1960, 1970, 1980, 1990, well, that's simple enough. Those are just years. But the other axis is going to have to go from 2,800 all the way up to 23,700. So clearly I can't go by ones because I wouldn't be able to fit anything. So now I have to think about what we're going to do. Also, all the data is positive. So we have another case where we can get away with just doing quadrant 1. So let's get started with that. And let's just set up quadrant 1. And we had 1950, 1960, 1970, 1980, 1990. We only have 5 years to put down. So maybe I'll actually skip a line. So I'll skip a point and put this as 1990. I'm sorry, 1950. Skip one and put this as 1960. So these are the points I'm using right here, 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 and here. But now the salary is the tricky part. What can we do to get all the way up to 23,700? Like, what can we do with the y-axis? I can't go by ones. 1, 2, 3. I would only get up to 14. What can we do, Ethan? Yeah. Okay. But if I did that, what would be the first number I would need? Right, and then I would need this number all the way at the top. So I still have a very broad range. So you're right, I could break the graph, absolutely. That's called a break. He was referring to doing this, where you put a little zigzag to break the graph that lets you jump from 0 up. But even doing that wouldn't help that much because we would still need to figure out how to stretch the graph out. So what else can we do? Okay, let me do it differently. Go ahead and using your pencil, lightly fill out the y-axis the way you think it should go. Take 30 seconds. Okay, but you can't do that. Because that's not the same distance as that. It has to be the same distance. All right. Even if you're not done, what'd you do? Tell me your first right here. What'd you put right there? Gloria? I'm sorry? 5,000. Okay. Mark, what did you put right there?
2,800.
2,800. Okay. So we have a difference of opinion. If we put 5,000 right there, that means that we're going to have to graph something off the grid again. And so you also have to pay attention to the fact that you don't have to put these exact numbers on the scale. We're going to have to do some estimation no matter what. We want our scale to be nice and friendly. So I wanted to see what you were going to do, but what we really want is to either go by 1,000 or 2,000. You also have to remember that the distance from here to here has to be the same as from here to here. So you could not do this. You cannot do 2,800, 4,800, and then 8,300. You can't do that. That's not the same distance. Plus, that means this is a distance from here to here of 2,800, a distance of 2,000, and then a distance of what? 3,500. The distances are all different. They have to be all the same. So some of you are making it way too hard. So keep it simple. You want to go a little bit below your first number and make it a nice friendly number. So start at 2,000. And you want to go all the way up to a little bit higher than your biggest number. Nice and friendly, 24,000. So go by 2,000s. 2,000, 4,000, 6,000, 8,000, and so on. So, general rule, you want your labels on your axis to be nice, friendly numbers. Because the data, even though we have these data points, we're going to have many, many more. When you're doing research, you're going to end up with hundreds of data points. And if you try to just put the first set of data points and use those to label your axes, you're going to end up making yourself really miserable. We're going to do some estimation no matter what. So now, what are the ordered pairs? Mark helped us out. This is the x, and that's the y. X, y, x, y, x, y, x, y. We have 4 ordered pairs here. So, 1950, 2800. Well, that's close to 3,000, and 2800 is a little bit less than 3,000, so I'll go a little bit below that, and I'll put a dot. And the next one was 1960, 4,800. So go to 1960 and go, well, 4,000, 6,000, 5,000 is halfway between, and 4,800 is a little bit below that, so put a dot. And then we've got 1970, 8,300. 1970, and there's 8,000. 9,000 is up here, 8,300 is going to be just a little bit above the 8,000, so right about there. And then we've got 1980, 15,400. So now we've got 14,000, 16,000. 15,000 is halfway, but then we got 15,400, so we're going to go up a bit, right about there. And then we've got 1990, 23,700 is very close to 24,000, right there. And so, from the data and from setting up a quality graph, we are able to see the trend of the data very easily. Any comments or questions on how we went from the table to the graph? Comments or questions? Concerns? And then you need to label your axes. So these are decades. Excuse me, that's decades. And this is salary. Salary in dollars. So now we have a complete graph. Anyone have any comments or questions? What type of correlation do you see? Bontravius, what do you see? Andrew, what do you see?
Positive correlation.
Tatiana, what do you think? Yeah, I think it's positive. Very good. All right. Any comments or questions on creating a scatter plot? All right, checkpoint number 1. You do not have to copy anything, but you need to create a scatter plot from the data. You got 4 minutes. Again, not too conducive to sharing out, so I'm just going to reveal the graph. This is what your graph should have looked similar to. But as I walked around, I saw a lot of different scales, and that's totally fine. I saw some people went by 6s, by 7s. That's fine, but remember a moment ago I said we wanted to be nice and friendly. Going by 2s is nice and friendly, by 5s, by 10s, nice and friendly. There's nothing wrong with going by 7s, but it's not the friendliest number to work with, especially when you get higher and higher. If you had to extend this graph more and more, it becomes more and more of a pain to work with. But no matter what, your graph should have had this same pattern to it. Any comments, questions on constructing a scatter plot? Give me a thumbs up if you got the graph. Good, put your thumbs down. Any questions at all? Okay, so now let's talk about correlation. Remember that the correlation refers to the relationship between the data. So here were the 3 different kinds: positive, negative, or no correlation. Any questions about this again? This is the same thing I had up a little while ago. So now let's use this and let's look at some graphical scenarios, and we're going to look at some verbal scenarios. You do not need to copy. You need to write example 2, part A. So you do need to read the instructions because you're going to see the same instructions in your homework, on quizzes and tests, etc. So look at the graph, look at the scatter plot, and decide for yourself whether you think this is a positive correlation, negative, or no correlation. Okay, let's survey. Give me a thumbs up if you think this is positive. A positive correlation. Okay. Put your thumbs down. Give me a thumbs up if you think this is a negative correlation. Okay, no correlation. Good. This is a positive correlation because you can see that as this number increases, this number increases. So it is a positive correlation. Excuse me. Positive correlation. And yes, spelling counts. Positive correlation. Anyone have any comments or questions on how we figured that out? All right, what about this? You do not need to copy, just write part B. A snowboarding competition and its development over the years. First competition was in 2001. This competition was in 2006, and we don't have data for 2007. Here's the number of participants in the competition. So what is the trend? What is the relationship? What do you think it is? I'm not going to survey this time. This time you raise your hand. Let's see if we can get some confirmation from a bunch of people. Got Isabella, Daniela, and then Sean. What do you think? You think it's positive? You all think it's positive? Yeah. This is another positive correlation. As the number of years get higher, the number of participants gets higher. Does anyone have any questions about that? So those weren't too difficult. Let's get to verbal, where you're going to have to read a little bit. So now we don't have a set of data. In example 3, we're going to look at a scenario and we're going to think about it. We're literally going to ponder it and say to ourselves, what do we think would happen? Unfortunately, in these cases, you have to have some understanding of the scenario itself. So the instructions say to identify the correlation, you would expect to see between the pair of data sets, and then explain. Part A, the average temperature in a city and the number of speeding tickets given in the city. Would you expect to see a positive correlation, a negative correlation, or no correlation between the temperature in the city and the number of speeding tickets? So, what do you think? Start with Deja, Jacob, Von Travius, and then Melinda. Okay.
No correlation.
Okay. I'm sorry? No correlation? Positive? Okay, so we do have some disagreement. Ethan, what were you thinking? No correlation? Okay, so you do have to have some understanding of why someone would get a speeding ticket. So, unless you think that the average temperature could make people go bonkers and just start speeding all over the place, then you would probably realize that there's absolutely no connection whatsoever between the temperature and whether or not you get a speeding ticket. So there is no correlation between the two. Now, someone could prove that there was a correlation, but they would have to do extensive research and they would have to be able to demonstrate that every time the temperature went up, there were more speeding tickets. And then you could say, well, it seems like a higher temperature means more speeding tickets. But this is not what it says. It says, what correlation would you expect to see? What would you think would happen? Okay? Melinda, does that make sense the way I'm explaining it? Good. Anyone have any comments or questions? All right, let's look at another one. The number of people in an audience and the ticket sales. Number of people in an audience and the ticket sales. So, think to yourself, would that be positive, negative, or no correlation? Positive, negative, or no correlation? What do you think? Let's do a survey this time. Give me a thumbs up if you think that's going to be a positive correlation. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, a lot of us. Okay, put your thumbs down. Give me a thumbs up if you think there's no correlation. Okay, give me a thumbs up if it's a negative correlation. Okay, 1, 2, 3. 1, 2, 3, 4, I think. Okay, so let's pretend that it's an empty auditorium and there's going to be a show starting. And you can only sell tickets, and one person can buy one ticket, and that's it. So if I sell 10 tickets, how many people are in the audience? 10. If there's 10 people in the audience, how many tickets did I sell? Okay. If there's 20 people in the audience, how many tickets did I sell? So they move up together, right? The audience increases, the ticket sales increases, this ticket sales increases, the audience increases. That's a positive correlation. As one increases, the other increases. And so this is positive. Any questions about that? Okay, no questions? All right, I have another one, but I'm going to start accelerating so we can get to the most important part of the lesson. So I'm going to give you a checkpoint and see how you do. You do not have to copy anything except you need to write checkpoint number 2, and then you need to read A, you need to read B, and write your answer. So we'll call this one 1.5 minutes. All right. So let's look at part A. Part A, give me a thumbs up if you put positive correlation. Thumbs up if you put negative correlation. Thumbs up if you put no correlation. Heavily no correlation. There is no correlation. The temperature in Houston has nothing to do with the number of cars sold in Boston. Part B. What did you put? Give me a thumbs up if you put positive. Thumbs up if you put negative correlation. Thumbs up if you put no correlation. So this was a tough one. You had to think about it, but this is a negative correlation because the more times you sharpen the pencil, what happens to the pencil? Kianis?
The length decreases.
It decreases. It gets shorter and shorter. So the number of times increases, but the length gets shorter and shorter. So that is called a negative correlation. Any questions? Okay, you guys have done a great job, and we're getting now to the most important part. So I apologize that it took us a while to get here. And I know that you may be feeling a little tired because it is difficult to sit through a long class. But I want to emphasize that your brain now needs to be in the highest gear possible. This is the most important part. So you can graph a line on the scatter plot. That's called a trend line. And the trend line is critical because it helps you make predictions. And that's the whole point, is that the trend line helps you make predictions. So let's now do one question from beginning to end, getting the data, making a graph, and figuring out a trend line. So, the table, don't worry about the bottom part yet. The table shows the price of a stock. For those of you who don't know what I'm talking about the stock market, stock in a company. The price of stock over an 8-month period. So the first month, the price was $32. Second month, $35, and so on. Part A, graph the scatter plot. So that we already know how to do. Part B, draw a trend line. That's what we're going to spend a little more time on. And then part C is the critical piece. Based on the line, predict what price we think it will be in the 10th month. That's the whole point of all of this. Now, I've set up a graph for you. I actually want you to do your best to copy the template of the graph I have. So I'm going to bring this down so you can see. And the program I used to do it didn't do the vertical lines. I'm not sure why, so I'm going to fill those in really fast. Let me see if I can do this. Yes? No, you need to go by 5. You got to do this. So it's going to be a bit of a bigger graph, but that's part of the point. So I took the element of deciding on what type of graph to make so that we could focus on actually plotting the points and getting a trend line. So give you a couple minutes to get this down. All right, so you should be just about set up. So let's take a look at the data. Unfortunately, I'm going to have to kind of move my screen up and down so we can see the table. So in the first month, the price was $32. So I'm going to go over to 1, and I'm going to go to 30, and it's going to be not quite halfway between. That's going to be my first point. Trying to be as accurate as possible with where the points are. Second month, 35. So now that's easy. That's right on the grid. And third, 37. Fourth is going to be 41, so just above the 40. You don't want it to be exactly on the 40, you want it to be just above the 40. And then 546. So again, not on the 45, but just above it. And then 650. That's easy, that's right on the grid. 754. And then 859. So just below the 60. So this is what the graph should look like. And there's the data that goes with it. So this is all ideas that we already know. Drawing a graph, plotting points, but now comes the critical piece, drawing the trend line. So as I demonstrated before, there's more than one correct way to do it, but you want to pay attention to where you put the line. So for example, let me do it wrong first. I'm going to start here and I'm going to try. So I'm going to start like this. Now I want you to look, and let me move this up now. I want you to look that I've actually crossed over the first 3 data points, so my line is actually perfect for those first 3, but then what happens? My next data points are actually rising faster now. So this line does not do a good job of representing the trend. So I need to adjust it. Now, unfortunately, on your papers, it's hard for you to draw a line and then adjust it. I have a computer that's helping me do that. So what you need to do is take your ruler, without drawing a line, you need to look at whether or not you have the same number of points above and below. And so I'm now going to adjust my line. Let me see if it will let me do that. Nope, wrong thing. So let me actually get rid of mine and redraw it. And so now, if I try to take a lower starting point, and this time try to go up in this fashion, so now look what happens. So now, I've got my line to cross over 1, 2, 3, 4 points. So I've got the line to hit 4 points. And I've got 1, 2 below the line, and then I've got 1 above the line and 1 partially above the line. So I've done a good job of balance. And that's the idea, is to try and get it balanced so that there's the same number below as above. Does anyone have any questions on how we drew the line? Give me a thumbs up if you were able to draw a line similar to what I did. I mean, there's no way to know if it's exact, but it should be close. Good. Put your thumbs down. So now, that was the critical piece, being able to decide on a trend line. But now, in part C, make a prediction. You see that the graph that I had us use actually goes all the way up to 10 months. We only had data up to 8 months. But now we can make a prediction. This is incredibly important in the world of business and finance. If you want to make money, you have to have an idea of what's going to happen in the future based on evidence. So if this is a performance of a company, then if I invest money in the company, then I think that I'll make some money around there. So now let's look at this point right here. And what do we think that point is? So now come across on the y-axis, and it looks like the point was just below the 65. And so what we could say is that based on our trend line, that this would be approximately $64 at the 10th month. And so we were able to make predictions. We could also go backwards and make a guess as to what it was when the stock first came out. So if the stock was at 1 month was at around 32, we could guess that it started at about 28 or 29. We can also make a guess at anywhere in between these points. And that's the whole idea behind the trend line. Okay? And so that's what we've been building to. We've only done one example, and one example takes a little time. So unfortunately, it's not enough for you to be an expert, clearly. So the homework is going to involve doing the process a couple of times. So your homework is on page 155. You're going to do numbers 1 through 8. And on page 156, you're going to do numbers 1 through 8. And your next assessment is your quarterly, which will be on Thursday.